Alright, we're going to discuss half-life, and for a quick reminder what half-life is, when we talk about half-life, we're talking about radioactive material. And in essence, what this half-life idea is that whenever you have anything that's radioactive, remember, radiation is a natural way for radioactive material to go back to a balanced state. They release radiation. And it takes a very, very long time, depending on the size of the sample, for this radiation to go away. So the idea of half-life is a way to measure how far or how long this stuff will actually take to go away. For example, if you have a 100-gram sample of uranium, for example, let's say it's uranium-236, and let's say the half-life of uranium-236 is 10 days. 10 days for every one half-life. Well, what that means is that after every 10 days, half of the uranium will have released enough radiation to have reduced the radiation amount by half. So let's put that into practice. If we take 100 grams and we divide it by 2, at the end of our first half-life, we end up with 50 grams. If we go ahead and take that and divide it by 2 again, we are at 25 grams, which is technically our second half-life. Divide that by 2 again, you end up with 12.5, which is technically our third half-life. So if we're looking at a 10-day time span, this is 10 days, this is 20 days, and that's 30 days. So it's going to take 30 days for us to go from 100 grams to 12.5 grams, which is 3 half-lives. So let's put this into practice. This was your paper. If you don't have this paper, you can go ahead and write down and copy the question, but this was in your handout. So the half-life of radon is 3.8 days. How much of a 100-gram sample is left after 15.2 days? So there's a ratio in here, and the ratio is that for every 1 half-lives, we have gone 3.8 days. Now again, this is the ratio given to you at the beginning of the question. Now what we have to do is say, well, if you started off with 15.2 days, what would a 100-gram sample be left over after so much time? So if you remember, we have days on top, days on the bottom. The days end up canceling and we end up in half-lives. So you will divide 15.2 is going to get divided by 3.8. And you're going to get, 4 half-lives. So we're going to take, now that we know our number of half-lives, which is 4, we're going to take our 100-gram sample and divide it in half 4 times. So let's start off. At 100 grams, the beginning of our stabilization, the beginning of this sample giving up radiation, we are at 0 half-lives. Why am I writing F? It should be an L. Half-lives. So if you divide it first, the first time you divide it by 2, and you get 50, that is technically your first half-life. Remember, we're trying to figure out 15.2 days, 4 half-lives, so we're going to have to do this one more time. Divided by 2 again, we get 25. That is our second half-life. Divided by 2 again, that gives us 12.5. That is our third half-life. And then we're going to go ahead and divide that one more time. I'm totally running out of room. And we end up with 6.25, and that is our fourth half-life. So how much sample from the original 100 grams is left over after 15.2 days? We ended up with 6.25 grams of our Radon 22. It went through 4 half-lives.